What's up guys, welcome back to another Coding Kaiju tutorial. My name is Diego. Once again, we're going to pick up right where we left off. Okay, so last episode, we implemented shooting our asteroids. But, like I promised, we want them to actually explode into smaller pieces. But before we get to that, I did notice a bug in our code so far while I was making this next part. So let's go ahead and fix that first. So the bug happens in our laser scene. So let's go ahead and open that. And let's go ahead and open the script. This is the line where the bug was happening, line 17 here on my code. Get parent, remove child self. What was happening is I was getting an error saying you can't call the function remove child on a null instance. Basically, get parent wasn't working because the laser had already been freed from the scene as we were running this code. So what was happening was that the laser had already been queued to be freed. So this is a pretty simple fix. You'll remember it's the same as our asteroid where we use this boolean here to make sure that explode hadn't already been called. But I'm going to show you a different way here to solve that. So right here in the if statement at the beginning, I'm going to do an exclamation mark, and I'll explain what that means in a second. I'm going to do self.is underscore queued for deletion, tab to autocomplete, space, and. All right, what does this mean? Basically, we're checking if the laser itself has already been queued for deletion. And if it has, we're not going to continue with the rest of the code. And this exclamation mark is the not operator. Basically, it means do the opposite of this line of code. So if the laser is queued for deletion, so if it's not queued for deletion and it's in the group asteroids, then continue with this and queue free. And this will solve that null instance error I was getting. So with that, our bug should be fixed. So let's continue on making our game. All right, let's open up our game scene. And what I'm going to do is I'm just going to move the player a little bit closer to the bottom of the viewport here. This thin blue line is our game's viewport. I don't know if you can see it in the video, but that's the viewport we defined. And now let's open up the player's scene and open up the script. And we're actually going to delete these two up and down input actions because we only want the player to be able to move left and right. All right, one more thing with the player scene. With the player, we want it to explode when it's hit by an asteroid. So let's go ahead and implement that. So to do that, we're actually going to add a new node. And we're going to add a node of type area 2D. 2D area for detection and 2D physics influence. Go ahead and add that. But first, let's rename this. And this is actually going to be the hitbox for our player. Now let's add that shape, collision shape 2D. And we need to add a collision shape. But what I want is for just to use the same shape that we use for physics interactions as the hitbox. So an easy way to do that is to go over here to the collision shape that we defined here. Click the little drop down arrow and click copy. Over here, back to the hitbox collision shape, click the little drop down arrow and click paste. Now it is the same shape. Now it's not a copy of the shape, it's actually the same exact shape as it exists in memory. So go ahead and select the hitbox again. So the reason we're using an area 2D here is because we get access to these signals here. So let's go ahead and choose the body entered signal and connect that to the player. And it'll generate this on hitbox body entered function for us. So this is going to be pretty similar to our other ones we've coded so far. We're going to use this if it has not already been queued for deletion and the body is in the group asteroids, then we want our player to explode. But for now, we're just gonna queue free it. All right, one more thing, bear with me. If you look at our game, our player's pretty big. Takes up a pretty big chunk of the window. This game's all about shooting the asteroids and dodging them, but when they're playing it, I want the player to feel more. I want the game to be more about shooting than dodging. So in order to make that happen, let's make the player a little smaller so it's much easier to dodge. So go ahead and open up the player scene again and go over to the inspector window here. And we're going to modify the scale property here. Now make sure you have the root player node selected because we want this to affect all the child nodes. Go to scale, and I found 0.4 to be a good value. Now if you want, we can go ahead and test this. Go ahead and run the project. And look, our player is tiny now. And it's much easier to dodge all these asteroids. All right. You know what? I'm actually going to move the player a little closer to the bottom. All right, we took care of some of the player stuff. Let's finally get to the good stuff. The asteroid breaking in to multiple pieces. So go over here to the file system window and click on the asteroid scene. So our smaller asteroid pieces are just going to be more asteroids. So go ahead and right click that and let's duplicate this scene. And we're actually going to call it Asteroid Small. Go ahead, duplicate and open up the Asteroid Small scene. The root node is still called Asteroid, so for consistency's sake, let's rename that as well. Asteroid Small. We open up this script. And it's actually using the same script, Asteroid GD, as the original asteroid. But what we actually want is it to extend this script so that we inherit all its functions and variables. So go ahead and right click on Asteroid Small and click on Extend Script. This little window is going to pop up. So we're going to inherit from asteroid.gd, and the new script is going to be called asteroid small.gd. Go ahead and create that. And you'll see that it's extending from our asteroid.gd script. All right, Control S to save. So what do I mean when I say we are extending a script? Basically, all the code here, all the functions, and all the variables we've defined in asteroid.gd are now present here in asteroid small.gd because it is extending the script. And what we're able to do is we can override functions. So we can actually define a new explode function that, has different code within it so that the smaller asteroids act differently than the larger ones. And we're actually going to get to that a little bit later. All right, next we're going to want to change the sprite. So this is a small asteroid. So let's go ahead and click the little drop down arrow and click load. assets, images, asteroids, and we're going to choose meteor gray small one, and go ahead and save that. And now we also need to fix the radius of our collision shape. So instead of 42, the smaller one's going to have a radius of 12. All right. So now what we want to do is actually spawn these smaller asteroids when an asteroid explodes. So open up the regular asteroid scene and open up its script. And let's load up our smaller asteroid scene. So let's make a new variable and call it asteroid small scene. And I'm going to call the load function. And remember, we can just come here to the file system window and click and drag, and it'll automatically populate that file path for us. So let's create a new function to spawn our smaller asteroids. I'm going to call it spawn asteroid small. And the first thing we're going to do is instance our asteroid. So let's create a new variable, asteroid small equals asteroid small scene dot instance. Then, of course, we're going to set the position of it equal to the position of the asteroid. And finally, we want to add it to the scene tree. Just to reiterate, when we name a function like this beginning with an underscore, we mean it to be a private function, meaning that only this object, only this script will call this function. No other nodes or scenes will call it. So let's go ahead and add it to our explode function. Spawn asteroid small. Now let's go ahead and try running our project. So now when we shoot one of the bigger asteroids, a small one appears. But you notice when we shoot a small one, the same thing's happening. It's actually spawning a smaller asteroid as well, which is why it's suddenly slowing down, because it's actually spawning a new one. Let's go ahead and close that. Okay, so now that we can spawn one asteroid, when our larger asteroid explodes, we actually want to spawn 4 smaller ones, since they act as the debris of the larger one. So we're actually going to create a new function for that. I'm going to call it func underscore spawn asteroid. I'm going to call this one spawn asteroid smalls. If that makes sense, basically just the plural form of this one. To say that we're spawning multiple, and we're actually going to pass an argument into here, the number of asteroids we want to spawn, and I'm going to say that is going to be of type int. I'm going to use a for loop for I in range of whatever number we passed in. We want to spawn a small asteroid. All right, so now let's change our lineup here to call our new function and pass it a value of 4. So now when we run it, four asteroids are spawned. All right. Obviously, we don't want all the asteroids to just spawn in the same spot. We want them to shoot off in different directions. So we have to give each asteroid a random trajectory. So let's go ahead and create a new function for that. So I'm actually going to put it down here under our spawn function. I'm going to call this one randomize trajectory and give it an argument of asteroid. So the first thing we want to do with our asteroid is give it a random spin. So I'm going to write a comment here, explain that. And we're going to say the asteroid, the angular velocity of the asteroid is going to be a random number in between -4 and 4. Like I said before, I found that gives a good value for a natural spin. And then, of course, we want to set the damp to 0 so it doesn't slow down over time. Okay, so next we want to send our smaller asteroids flying off in random directions. So that is with the linear velocity property, which is of type vector2. And we're going to give it a power of 400. But like I said before, we want it to be a random direction. Well, what we're trying to get here is we want this to be a value of 400, -400, or 0. And a way to do that is to multiply it by a value, basically one of those values. Multiply this 400 times 1, or times -1, or times 0. And in order to get that random number, we need to generate it. Really quick though, let's add the damp. Linear damp equals 0. Okay, so in order to generate a random integer, we're going to have to actually define a new variable up here, because we're going to use another built-in class in Godot. I'm going to call this variable RNG, and it's going to be of type random number generator. That's what it's called, and we're going to create a new instance of it and store it in our RNG variable. Then we're going to create our two variables. So the x value of our random linear velocity is going to be RNG, and we're going to call this rand I range function, which is similar to the rand range function we've used before, which generates a random float within the range we define. This generates a random int or integer in the random range. So like I said before, we want it to be 1, 0, or -1. So calling this like this here will get that for us. And let's do the same with a y value. So we take those values and multiply it by 400. And then this is how we're going to get either 400, -400, or 0. And the reason we're not using a float here, in case you're wondering, is because if we use a float, then it's possible to have a random value of, say, close to 0, 0.001, or 0.3, and we want the pieces to fly off in random directions, to shoot. If it was a low value, like 0.001 or 0.3, it would just slowly float away in a random direction. You can try that yourself. Instead of using this rand I range, use rand range to generate a float. And then one more thing, something I didn't mention in the last video. If we want to create truly random numbers, or more random at least, we have to call the randomize function on our RNG object, our random number generator. And this will actually take the current timestamp in the operating system and use that as a seed to feed the random value. And this will give us more random values than if we didn't use it. So let me just write some comments here, explaining what's going on. All right, so let's go ahead and try this. And it looks the same. Why is that? Well, we actually have to call this new function, Randomize Trajectory. So let's call it right under here, under the where we set the position, Randomize Trajectory, and we're gonna pass it the small asteroid defined here, so that it's passed into here, and that'll be corresponding to this argument, and then its properties will be set. All right, and now we have the pieces flying off random directions, and sometimes some of them stay where they are, and some of them end up shooting towards the player, so that it's dangerous to stand still if you're shooting an asteroid right above you. All right, that's looking pretty good. All right, so one more thing we want to do is actually go into our small asteroid and go into its script. We're actually going to overwrite the explode function because we don't actually want it to spawn smaller asteroids when we shoot a small asteroid. So let's go ahead and copy that explode function and paste it into the asteroid small script, because we want it to do the same thing, but we don't want it to spawn the smaller asteroids. So by removing that line, we're going to get rid of that functionality only for the small asteroids. Now we can go ahead and test this. Let's see if I can get a small asteroid. There we go. Now the small ones just disappear. All right, I think we are ready to add some sound effects. The first sound effect we're going to add is going to be for our laser scene here. So go ahead and open up the laser scene. And we're going to add a new node of type Audio Stream Player 2D. You'll notice there's 3 different kinds of audio stream players right here. This first one's just the regular audio stream player. You can see there it plays audio back non-positionally. So that's good for things like, music, soundtracks, things like that. Then we have the Audio Stream Player 2D, which plays sounds with 2D positioning, on the screen. And then obviously 3D, which has, the left, the right, and a depth value as well. So we want 2D for our laser. So go ahead and add that. And we're going to set the stream property, and we're going to load up the sound file. So go ahead, open up the assets folder, and instead of images, we're going into audio and sound effects. And our laser is going to use the laser shoot .wav file. And here you can see all the properties we can set. And we're actually going to enable autoplay. What autoplay is going to do is it's when this laser object is first instanced into the game, this sound will automatically start playing. You can also set the volume of the sound here and the pitch, just in case, so you can edit the soundscape of your game, how loud some sounds are relative to others. I've already messed around with the volumes of all the sounds in the game. So I'm actually going to set this to -7. You can also obviously do your own sound tuning and just leave it at 0 for now. And as you add more sounds, tune them appropriately. So let's try running the project now. When we shoot lasers, they make sounds. And if you listen closely, you can actually hear the laser. If you're wearing headphones, you can actually hear the laser travel upwards. Alright, now let's add a different kind of sound. We're going to add this to our asteroid scene. So it's going to be the same thing. Go ahead and add an audio stream player 2D. And when I say a different kind of sound, we're actually going to be adding a continuous sound. Go ahead and open up this one, Gentle Roar Pink Noise. And that'll be the sound of the asteroid flying through space. Of course, in real life, sound doesn't travel through space, but this is a video game, so it's all about how it feels, more than what would be realistic. Then, like I said before, I've already messed around with the audio levels, so we're gonna set this one to -10. And we actually want this to be a little deeper than the default sound. So we're going to set the pitch to half of it, so 0.5. And we want this to loop. So in order to make this loop, we're actually going to go to the import tab here. And we're going to open up that file here, Gentle Roar Pink Noise. And we're going to turn on the loop option, and don't forget to click re-import. And you'll see on this side over here, all the loop properties are here. So we're actually going to set the loop mode to forward. Okay. And then just like the laser sound, we want this to autoplay. So go ahead and enable that. So I don't know if you could hear it, but you can actually hear the asteroids despawn, because when they go off the screen, the noise for that asteroid stops. All right, we're gonna stop this video here. Be sure to like the video if you liked it. Subscribe if you want to be notified when the next video comes out. And thanks for watching.